All right, now that we talked about the web-based games and multiplayer gaming technologies, and then we talked about topologies and architectures that can be used for multiplayer gaming and game networks, we'll talk about a very important topic here, and that is security. When you're creating a multiplayer game or a virtual world, you end up also creating a hidden social game. It's basically you versus the world. The only rule that's for sure, and it's basically created for this instance and for the social game, is that you'll never know what they are going to try until after they've done it. Your only defense is to be armed with the knowledge and be proactive in development. That doesn't mean that you are sure a loser in this case. It just means that you need to keep on your toes and also roll with the punches. In other words, security is a word with many contexts and meanings when it comes to multiplayer content. Because before you decide to simply think about developing your game, you need to essentially look at your world, virtual world, in the game, and want to make sure that it won't get hacked, and that how you can establish mechanisms and basically checks and balances to avoid your game to be essentially broken by the players. We will discuss a variety of security topics, from keeping the application safe to keeping children safe. By applying the information that we talk about in this next few slides and in about this next hour, we will be able to dramatically harden our applications, either a game or a virtual world or a social setting or a social game, and also to protect ourselves from malicious users. As programmers, ask programmers about security and they will talk about securing their code. If you ask the parents about security, you would probably get a completely different answer. Most of the things that we will be talking about as far as the security is basically discussing physical application security. Before we look at physical application security, we need to look at a different location or a different direction, and that is called logical security. More specifically, about making a virtual world a secure environment for the participants that are participating in this world. In this context, security and privacy go hand in hand. The best way to maintain security is to provide anonymity to your participants. This often goes against the goal of your project, because usually using anonymity to your participants dramatically limits the usefulness of the worlds as a marketing platform if you were aiming for marketing, as we talked about earlier. The entire topic gets into a lot of potential legal concerns when it comes to security and privacy and other issues. So we will first try to lay out various concepts and things to be aware of, and then we will basically leave that to legal advice if you were to establish and deploy a larger, secure multiplayer environment that you would have to look at specific laws that apply to it. Before we talk about the physical security of our platform, let's just discuss something that's called COPPA, or the Child Online Privacy Protection Act. Child Online Privacy Protection Act is a legislation that intends to protect children when they are online and on the internet. The law is targeted most directly, but not exclusively, at companies providing online services to kids, from chats to articles to games and other services. The main push of the law is around collecting data and parental approval. In general, it's best to avoid collecting anything that is personally identifiable. At the very simplest level, this means that you shouldn't ask for a full name, address, or phone number during account registration. But this is just an example. In general, the less data you capture, the safer you are. It's important to seek legal counsel before you're actually deploying a game or a entertainment service for the minors. So you need to basically seek legal advice if your targeted audience are minors and children. Socializing is a huge aspect of virtual worlds, but it's also considered a large risk factor. The ability for players to chat directly with each other makes the world more immersive and fun. At the same time, it exposes users to potential abuse. Parents always are concerned about their children being brought into contact with online predators. The most common and simplest way to eliminate the risk or the risk of open chat is to remove open chat altogether and only support list-based chat. Open chat is the ability to simply type a message and send it. List-based chat allows the user to select and send a pre-written message from a list of possible messages. This prevents the users from sending or receiving information they shouldn't do. That's really basically the crux of the problem. How do you prevent predators from getting information such as names, addresses, phone numbers, and personally identifiable information from other players that they shouldn't have? If the world that you are creating supports open chat, then the protections should basically put in place as far as chat filters, moderation, and parental controls. And basically, for your parents to be able, for the parents of the children to be able to say what kind of conversations the children could participate in and what they shouldn't through an admin panel. But aside from the technical issues and liabilities that come with the certain kind of entertainment and socialization websites whose primary audience are children or minors, physical security basically is the process of actually preventing hackers from getting at your data or damaging your application or the user experience. And this is what we will be discussing a lot in this section. There are many layers to application security, with each layer protecting different parts of the system. We will cover general security rules and practices, as well as dig into specific attacks that are more common in a web-based game or a Flash application. Let's first look at the problem. The problem ultimately is a simple one. How do you create a virtual world in Flash or any other web-based game that is hacker-proof? The answer is that you don't. If your world is on a server that connects to the internet, it is ultimately vulnerable to attacks and hacks. The trick is to shoot for it's not to shoot for hacker-proof systems, but is to shoot for making it hard or as hard and unrealistic as possible to hack into it. The vast majority of hacks and exploits come from simple oversights, which, if addressed, immediately makes your world dramatically harder to hack into. With a few precautions and a little knowledge of what can be done to avoid hackers to hack into your system, you'll be able to secure and ensure that your world is protected as well as it can be. So we'll explore the basic tenets and rules for building a virtual site that is secure and reliable for players to play in. You should consider each of these rules when building a new piece of functionality and apply them as aggressively as you are able to do so. Doing so will dramatically strengthen your project. One of the basic things that you can do is to minimize the surface area. The idea behind attempting to minimize the surface area of your application to the hacker is basically simple. You want to reduce what they can access and use against you. This is basically an overreaching concept that you apply to everything in your world, from servers to code to data and so on. For instance, let's say that you're passing data about users from the server to a client. Some of the data is required and some might not be required, but it's easiest for a developer just to send everything. This is always a bad idea. Who's to say that the data you sent back doesn't provide the final key that the hacker needed to exploit your system? Not only are you wasting bandwidth by sending everything from the server to the clients, you are also needlessly providing the data that could potentially be used against you. For example, the original Echeron's call game used to send all the information from the server to the clients about all the collectible items that were spawned in the map. And they would send it for a large area, not just the immediate surrounding area about the player. This would allow the game client to properly render the items on the ground when the client player got close to those items. The problem in this case was that the server sent the information for a large area rather than only for immediate area surrounding the player. It was a huge mistake because the hackers could create a tool, and they actually did create a tool, that would show where all the spawn items were on the minimap, and it would make it easier to find and collect the items. The hackers were rewarded with a lot of information and a lot of items because they didn't have to look around for them. They already knew where these items were as soon as those items appeared and were spawned on the game world. To minimize your surface area is basically very critical, and it basically ensures that there's as little possible available information to your users to use against you. If you don't need it, then don't include it. The second idea in this case is obscurity is not security. This is a common misconception that leads to a huge number of problems. Just because something is complicated doesn't mean that it is secure. When you write a code and you want to secure a score, for example, you should not assume that basically going back and forth and adding and multiplying these numbers to some arbitrary numbers, you could achieve the same result as in encryption. In fact, Flash games are easily decompiled, and once someone can compile this application, it's very trivial to look for and work your algorithm backwards and find the important pieces of information that you included. True security is when the hacker knows exactly how it works and still cannot break it. So for example, for this case, if you need to send information that need to be sent back and forth in a secure way, you should basically make sure that you use an encryption mechanism. Trust no one. As we stated earlier, Flash is easily decompiled, and you can also easily reverse engineer an application, even in more concrete programming languages such as C#. When writing your application, you should assume that a hacker can figure out how the clients basically do things, for example, submitting scores and so on, and so you have to protect that from the client. Allowing the server to help with validation of the data or handling the data in the first place is a very good choice. You'll see examples of server-side validation or processing on the server side throughout this class. A good real-world example is basically the chat client that's developed as Electrotank based application tool. It uses HTML to display the chat text in various colors based on who was talking and if the message was public or private. To ensure the HTML was well formatted, the Flash client provided some level of validation to chat messages before they were sent. Some hackers, with this particular example, could basically went about creating a version of the client they could run locally, and then they removed the HTML validation checks. Since the server assumed good behavior on the client side, it let the hacked text go through. So the hackers then could do any number of things to cause problems in the chat room. They could send an HTML that was embedded, or that basically embedded images into the text field, formatted hyperlinks, and send it to send the users to inappropriate sites, change the text size, and made things like text in the chat room ridiculously huge, and so on and so forth. So it's essentially important for you to make sure that your server would have a mechanism to validate things, even though you expect your clients to perform reasonably well. Which brings us to the point, validate everything. This goes in hand with the previous entry that we talked about not trusting anyone. You do not trust clients, and it's not just because your clients are always bad. It's just they may not do things really the way that you expected them to do, either intentionally or unintentionally. You need to verify everything that your server sends back and forth, and also the clients are sending back and forth on the server side, and make sure that it never breaks the rules and cause problems. This validation is useful in general, as it will also assist you in finding errors with the client-server communication that you have set up. A good example of the importance of validation is with combat. Let's say that you have a gun in a game and that it can fire one shot per second. Each shot sends a message to the server, which is then broadcast to everyone else in the immediate surrounding of the player. The client code can use a timer to handle sending each shot when you hold down the trigger. A hacker could simply remove this delay per shot on their client side, and therefore instantly they would get a machine gun. The solution is to validate the number of shots that are being fired by every client and log any violation on the server. So if the server sees that there is a client that's sending shots with less than time frame that's supposed to be established per shot, then you would be able to notice that that might be a potential problem with this setting. It's also important to note that validation can occur on the client side as well as the server side. In a multiplayer game, the client is in a position to detect erroneous messages from the server and also to ignore them. Trap it all. Simply validating the information that goes back and forth between the client and server is a huge step in a more secure direction, but you should also code defensively. Assume the client will sell data that is wrong or is not formatted correctly. To this end, you should trap any error on the server and log them with as much information for you as possible. This will basically be your hacker early warning system. All entries and errors in the log will give you something to either fix or harden as needed. If you don't need it, remove it. This also goes along with minimizing your surface area. There are many tools installed on a physical server by default that give server administrators lots of functionality. But most of this, either the tools or the functionalities, are not needed to host a game or a virtual world. If you leave all of the default installed applications on the server, you might be exposing the server to hacks, and in any case, you're taking up space unnecessarily. The tool the hacker needs might be there because you didn't remove it. If you don't need it, remove it. A real-world example of this is that the Electro server development team experienced a few years ago with Cold Fusion. It was a server product from All Air and then Micromedia or Macromedia, and now with the Adobe. When you would install the Cold Fusion, it will also include a nice little set of examples along with the server. They were made available automatically over the internet when Cold Fusion was installed. One of them gave the ability to run arbitrary code posted through from a web browser. Hackers didn't take long to write some Cold Fusion code that downloaded and executed system-compromising utilities onto the server. All you had to do was basically to find a site with Cold Fusion examples on it enabled, paste them in a pre-written script, and then you had an instant hack. If the administrators of those machines had simply removed the examples from the production server, none of this could have happened. If you don't need the examples in production, don't leave them in the production server. Just remove them. Another step that you could take to secure your application server and functionalities that you provide your clients is to don't give everybody all the keys they need. We basically talked about how important it is to log information and things on the server. Now we'll just basically step back a little bit and look at it. Logging is very important for you because it lets you get the information you need to see what went wrong and how did it go wrong. But this information is also a huge amount of information for the hackers if they get their hands on. Basically, keep these kinds of log information out of the hands of those people that would cost you if they have that information. In practice, it's very simple. Most high-level web development languages basically try to give you as much information as possible when they encounter an error. For example, if you look at a simple ASP.NET default error page, you would see that it would give you everything. It would give you the stack trace, a trace of all the function calls and all the variables and parameters that were involved with that error. And this is potentially a big problem for you if some malicious users would get access to these kinds of error. They can exploit the vulnerability of your system if they know exactly what is going on with it. So in production, you should always use custom error pages and custom error messages and log the errors such that no end user can see them. But your production team will be able to access those end errors and all the details. This will give you critical information that you need while it will keep it from the praying eyes. Right now, you're probably thinking about, it's kind of crazy to do anything with multiplayer games and web-based games because it's a crazy world out there. However, there's a single tool that dramatically increases your server security across the board. It's called a firewall. A properly configured firewall is critical to securing your applications on the internet. While firewalls themselves are very sophisticated, the idea behind how to use one of those firewalls is quite simple. A firewall's job is to restrict access to the servers behind it. It provides a hardened front with only specific points of access and entry to limit the surface area of your application. In practical terms, the firewall configures, basically that's configured for a virtual world, looks something like a wall that is shielding your website, your game server, your database server, and your web servers away from the internet, and therefore making your production servers and your application much safer by nature and much more secure. As you can also see from this diagram here, only specific ports may be opened inbound to the servers. This is all part of limiting access to the servers. For instance, the web servers can be only called on ports 80 for HTTP and 443 for HTTPS, which is a secure protocol of HTTP. The game server is limited to run 9899 or port 9899, the default access server for binary port on Electro server. And we'll see these practical things as we go on and we install our Electro server and socket server and try programming it. In a real world scenario, there are likely other ports that you might leave open, for example, an SSH inbound or an email outbound SMTP port. The idea, though, is to minimize the access in and out of your environment. This will dramatically reduce the available options that are exploitable by potential hackers. Know your enemy. It is important to know that people most likely to exploit your system are looking to do it for fun. Sometimes they're power gamers and want the extra edge, or they want to just do something no one else can do for the ego stroking involved. In general, they're interested in taking advantage of your system rather than just crashing it down to the ground. Knowing this will give you an idea of the type of things they will try and the techniques that they will use. Expect them to be exceedingly resourceful and clever. The advantage you will have is that they have to work backwards from the game or the final product and discover the details as they go on, while you simply need to plan to secure up your application. So, in the next few minutes, we will explore the most common hacks against the applications in general and against Flash content in special. As part of this discussion, we will discuss how you can protect yourself from these kinds of attacks. There are certain kinds of potential attacks that might happen, and if you know about these and know how you can avoid each of these um, attacks, you could secure up your system. These are a list of these kinds of attacks as exploiting your game behavior: SQL injection, cross-site scripting, packet injection, message modification, and in-memory variable hacking. We will discuss these in detail a little bit later. Exploiting game behavior is almost certainly the first option or the first exploit you will see against your virtual worlds. Game exploitation is made possible by a design flow problem or a design flaw, or a poorly thought out piece of functionality that a clever user will take advantage of for some gain in the game. A good example of this is a mini game that can be slowed down with a CPU slowing piece of software, such as a CPU killer, and thus easily won. If the developer didn't clamp the maximum money for winning the game, this might make it possible to make lots of money by playing the game over and over and getting very high scores because the game is now so simple to win. As always, the first step to preventing this is to clamp values and validate input in the first place. But one specific way to prevent the slow down trick is to use time-based animation versus frame-based animation. This will ensure that the objects on the screen move the same distance no matter the CPU speed. The ultimate fix for this is testing. Make sure your game doesn't have easily exploitable loopholes. SQL injection is easily the most malicious of all possible hacks from an application point of view. It also is one of the most common. SQL injection is a process by which a hacker is able to inject an SQL statement and run it against a database because a lazy developer didn't validate the input or bind the variables. To really understand this, we need to get into specifics by an example. Let's say that you have a high score board in your system. The code to select a high score for a specific user looks something like this. It's an SQL command that says choose or select score ID, score, username, and date from a scores table where username is basically a hashtag name or the name of a person. And you assume that name is coming from the client somehow. A clever hacker can simply, instead of passing their name, they can pass a command like the second green line in this slide, drop table scores. The final command that will be run on your server looks like the third command here. It says select score ID, scores, username, and date from scores, where username is empty, and then followed by a SQL statement for dropping the scores table. The result of this is disastrous. What happens is that when this piece of code is run successfully, as the hacker wanted it to do, it will delete your scores table. This means that any code that attempts to access the table will fail from now on. This type of hack is both very dangerous and also is very common, so it's essential that you protect yourself from it all the time and at all cost. The good news is that actually preventing SQL injection attacks isn't difficult. The first step is to validate inputs. This is something you should always do anyway, so it doesn't really add extra work to your production. For example, if you are expecting an integer, make sure that its value is not a string. If you're expecting a string, make sure that the string does not contain any keywords from your developer application. The next thing to do is to escape any data that's passed in. There are various commands to help you with this process, but the best solution is to parameterize queries. Queries where you tell the system what the query is using placeholder for dynamic parts. Then you populate those placeholders at runtime. The escaping will be handled for you. Not only do prepared statements give you better security, they also improve performance. since they can be cached by the database. The final trick with SQL injection is simply to limit the harm. In the above example that we just saw here, the hacker was able to draw the database table. This can occur only if the database account would basically run the queries would dump tables that can dump tables. Well, this is not a good idea in general, of course, so you need to make sure that the commands that are coming into your server does not exploit or will not exploit your essentially commands that you will be passing to your application. Cross-site scripting is a very common hack for web applications. The basic idea is that input from the client is displayed without validation. This can be used to perform all sorts of dirty tricks in the web application. A common example that can happen with cross-site scripting is that a forum that doesn't validate and doesn't strip special characters could be hijacked with some JavaScript code in a forum post to redirect users to a different site. This is a bit less of an issue in Flash applications. Flash does not allow for dynamic execution in most cases. The specific area where this can be a concern is in the use of HTML for field formatting. If you had a chat box and the client sent HTML formatted message, basically it'd be possible to send a message with the invalid HTML that ruins the display for the users. For instance, the client could set the font to a very tiny size and change the color to match the box in the background, and nobody could see that. The solution in this case is to simply validating the chat message and stripping unwanted characters. For example, less than and greater than signs are used for HTML tags, and so you can strip out those characters out of your chat messages. This way, your users will not be able to send your HTML formatting tags to the chat side. Depending on the design of the system, this stripping could occur on the recipient client as well. If the text is sent in plain and any HTML is required when received, any HTML that was received is obviously invalid, and therefore it can be stripped out. This is a good example of where receiving client can act as at least a line of defense. Packet injection is simply where the hacker injects a packet in the stream of data to the server with the command he wants to execute. Basically, this is letting him program the behavior he wants to do and want it to occur automatically. Let's say you have a real-time shooter game that's become popular. A clever hacker could write a program that intercepts all the messages between the client and server, and thus it could build an in-memory representation of the game state. In this case, the program would behave like a proxy server. It intercepts everything and passes it along. This program could then be used to automatically send a shoot message whenever someone is in range. There are various solutions for preventing successful packet injection. First and foremost, you need to validate the data from the client to ensure that it's legitimate. Make sure the client is not sending shoot messages too quickly, walking through walls, or otherwise breaking rules of the game or its physics. Important decisions should never be made on the client side. They should always be made on the server side. This would prevent a clever hacker from being able to send messages with too much power, like death messages, hit detections, game state changes, and etc. Once you have ensured only valid data is being sent, you need to start hardening your product protocols. One effective approach is to number packets automatically as they leave the game and the server. This means if someone is going to inject a new packet, it will conflict with the number of packets that you had sent on the server, and this conflict will be detected in the server. You can handle this however makes sense for the game. For example, in the uses of applications that we will do, because Electra Server automatically numbers both inbound and outbound messages and tracks a duplicate, this will be taken care of for us. Another layer of security is controlling the format of the messages. If the hacker can't reverse engineer the messages, they won't be able to duplicate them. As we said before, obscurity is not security, so don't rely on complicated protocol alone. You need to use encryption for your protocols. If It doesn't need to be strong. It just needs to be hard to break. Various forms of TEA or tiny encryption algorithms, or even an XOR, are very effective. Electro server has built-in protocol encryption that can be used to help with this. The next potential attack is the message modification. Message modification, it's also can be considered as a brother of packet injection, is when the hacker uses a tool like Firebug, which is a Firefox add-on, or a homegrown proxy server, as we discussed earlier, to modify the messages that are being sent from client to the server. The hacker might modify an avatar movement message that would allow their avatar to teleport through walls. They might modify their attack message to do far more damage and adjust the aim to be perfectly accurate. The possibilities with this are endless because everything you can think of can be done by message modification if you know how to do it. The solution for preventing message modification is exactly the same as preventing packet injection. Encrypt your protocol, validate on the server, don't trust the client for important decisions, and so on. Editing variables in memory used to be easy for just the skilled hackers, but now there are tools that are available that almost everyone can do it. There are numerous articles that teach you how basically you can look at the content of the memory or even a compiled code and how you can look for specific things. The general process is to use a tool like, for example, Cheat Engine and tell it what process to hit. So, for example, you can target a browser. Then you can search for a known value. Let's say that you have a 20 piece of gold in game. You would search for an integer with the value of 20 in it. This might return hundreds of results because a lot of things in your compiled game would be referred to as the number 20. Then you log the results and do something to change that particular aspect of the game. For example, in our case, the amount of gold. Let's say you take it down to 2. Then you search for the original results for a number 10. At this point, you should have only a couple of valid results. And this way, you know what you're exactly looking for in the game and you can find it. This technique can be used to increase your score, to change the money, etc. Fortunately, the fix to this problem is basically the same as for others. In a multiplayer game, you simply don't trust the client, validate the inputs that are coming from the client on the server side, and don't let clients make important decisions. Another highly effective solution is to stop that would stop this kind of technique is to encrypt the variables that are in memory. By encrypting important variables, the hackers will not be able to find them as they're not stored in memory in a findable state. So far, we talked about client-server architecture. We talked about the basic peer-to-peer and client-server differences. We talked about polling and socket servers that are used in primarily client-server architecture for multiplayer games. We discussed the security, and finally, in the last few minutes, we discussed in detail different kinds of hackers and different kinds of tools that hackers exploit to attack your applications. And we talked about how you can secure this. So with this, we'll stop here, and next we will discuss the socket server that we will be using for our projects in the rest of this class, which is called Electro server. And we'll go about installing those the Electro servers 4 or 5. And also, if you don't have Unity, we'll also install Unity, and I'll show you how to do that. And then we can go about and talk about specific things in the Electro server, socket server that you would be using.